In this lesson, we will be doing applications of exponential functions, which involve exponential growth and exponential decay in some real-world problems. You'll notice that even though we still have a times b to the x, in this case, we're replacing the x with a t because we're usually doing problems that involve time. So a is still our initial value. T is the time that's passed. B is going to be our growth or decay factor. Remember from earlier in the lesson, if B is greater than 1, we have growth, and if B is less than 1, or between 0 and 1, we have decay. And our R, which isn't part of the equation, but it is used in calculating B, R is called our growth or decay rate, the rate at which something is growing or decaying exponentially. So you'll notice that if we're adding the growth rate to 1, we have exponential growth, and if we are subtracting the growth rate from 1, we have exponential decay. So now we'll try a couple of examples. In this example, Miss Adams' car was purchased in 2007 for a total of $21,000. It depreciates or goes down in value by 25% each year. And we want to know two things. What is it worth in 2018? And when will the car be worth $100? So I know that I'm dealing with an exponential function here. So I'm going to write down my general exponential form, y equals ab to the t this time, since we're talking about time. I know that a is my initial value of the car. So this is my a value. 2007 is just kind of our starting point. So it's telling us in 2007, no time has passed. That's our time 0. It's saying it depreciates by 25%. This is our decay rate. So R equals 25% or 0.25. And we want to know what the car will be worth in 2018 and when it will be worth $100. So I'm going to fill in what I can. My general function is y equals my initial value of the car, $21,000. And now I need to find B. Well, I have my rate, and I know that I'm going down. So B is just 1 minus my decay rate, which gives me 0.75. It's the same as 100% minus 25% gives me 75%. So my B value is 0.75. I'm going to put that into my equation. And then T is however much time has passed. So this is my general equation. To figure out what the car is worth in 2018, I need to figure out what T equals. Well, it's 2018 is 11 years after 2007. So if I subtract 2007 from 2018, I will end up with 11 years. So if T is 11, I'm just going to plug in y equals 21,000, my initial amount. My decay factor is 0.75, and I'm taking that to the 11th power. And when I plug that in my calculator, I get that the car is worth $886.94, which is about right for an 11-year-old car, although it does sound a little bit low. So that is part 1. What is the car worth in 2018? It's worth $886. The second part of the question asks me, when will the car be worth $100? And that I'm going to have to use my graphing calculator because I want to know, when does y equal 100? If I go into my graphing calculator and I graph y equals, if I graph my original equation in y1, and I graph 100 for y2, I can find that intersection point right here. And my intersection point, according to my graphing calculator, is 18.59, 100. In other words, after 18.59 years, the car will be worth $100. Well, 18.59 years doesn't tell me what year, so I need to figure out, well, in 2007, that was our original year, and I need to add 18.59 years. So it looks like it's going to be sometime in 2025 that the car will be worth that much. So we'll do one more example, and then there's some practice for you guys on the back. In this example, Miss Maloney's apartment is growing exponentially. As soon as I see growing exponentially, I know that I'm going to be creating a growth factor instead of a decay factor. So B is going to have to be 1 plus my 2%. Remember that 2% is 2 divided by 100, or 0.02. So my B value is 1.02. My initial value is $100,000. That's my A value, and it was bought in 2013. So that is my starting time. So again, I'm going to write my generic equation. I know that my A value is 100,000 and my B value is 1.02. So my function is y equals 100,000 times 1.02 to the t power. In this case, t is 2020, which is 7 years after she originally figured out the value. So 2020 minus 2013 gives me 7 years. That's for t. So in 2020, the house is just worth, or the apartment is just worth 100,000 times 1.02 to the 7th power, which just gives us $114,868.57, more or less, which seems reasonable for the appreciation of an apartment. So give the problems a try on the back. Don't forget to complete your survey, and I'll see you tomorrow.